Hello, good morning.
Hey,
Hi,
how are you?
good, how are you?
Good. I'm turning on video because we're gonna be here for an hour.
Yeah, my thought was, I just went through and I recorded the glomerular filtration activity. So I'm thinking, because I think that the acid base is going to take us an hour.
Oh, really?
Maybe less, maybe not. It just depends on how quickly, everyone kind of understands it. And I would just want to make sure that people that aren't watching this are also.
Yeah. You know what I did that helped a lot?
What's
That
that?
might help people that haven't yet done it. Your video is really good. So what I did is as I went through your video, I kept doing print screen.
Okay.
And then I take it over to Google Docs and I hit, I paste it there. And then
Okay.
what I did is I printed it out because
Okay.
it's not super hard if you know what
Right.
you're doing, but when you're first starting, it's
Right.
like, wait, so I really relied on your like
Sure.
help. So
Sure.
I just printed them out. So I have them for today.
Well,
So
that's good. Well, that's good. I want to go through them just because I'm not sure if, what other people are doing or how well.
yeah.
I've had some students that had no problems with them, and then other students said that they still are not understanding everything completely.
Yeah. I think what'll be hard is like on a test when you don't have like the cheat sheet, like when you're going from
you don't
memory.
have the numbers in front of you. You have to
Yeah,
memorize
so
those numbers.
it's going to take time to study and memorize, but
Yep, absolutely.
and I don't know what everyone else has, but I have the acid based on, I have the Anion Gap, but
Okay.
I've been sitting here working on, I just ran out of time, this
Yeah.
system, but I think that's pretty self-explanatory.
Yep. So let me just go ahead. I just want to share my screen and show you the documents that we're talking about. So this is the document that I recorded already on Zoom, and I'm hoping that I had a little bit of trouble with my internet. But I thought that what I could do is just let you guys watch on your own that Zoom recording. I did that right before our class started so that, I went through everything here. And so I'm kind of thinking that maybe I can just leave that and let you guys watch that Zoom recording if you didn't understand this at all, if there were things you didn't understand. Unless you want to ask me questions right now and I could answer questions. So the kidney is just so important for so many reasons, but a lot of cardiologists look at the kidneys when you have unexplained hypertension, like why does a person have high blood pressure? They'll look at the kidneys because there could be things going on in the kidneys that are causing the body to react and give a person high blood pressure. And so this activity sort of helps to see how that could happen. So I just kind of want to, if that's all right with you guys, I'm just going to leave that and let the recording, you can watch the recording later. And then if you still need help, then you can just make an appointment on Calendly with me. Okay, does that work out? Okay, then the other document that we have is this acid base, and this is the one that I want to go over with you. So let me get this out of my way here. Okay. So the first thing I just want to explain to students, because let me just go with a whiteboard. Wish I could get rid of that. There. Okay, so the first thing I want to do is I want to talk about, all right, the whole thing with acid and base. So your body produces acids, and they could be organic acids, metabolic acids. There's a lot of acids that are being produced in your body, and typically those acids are going to be in the form of carbon dioxide, or they could be in the form of hydrogens, right? So we have this formula that's CO2 plus H2O. That gives us carbonic acid. And that can be broken down into hydrogen and bicarbonate. All right, so the hydrogen is an acid and the carbon dioxide is an acid. So we can buffer this, and in order to buffer an acid, there's different buffer systems, but the one that we talk about mostly is this carbonic acid bicarbonate buffer, where we convert hydrogen and carbon dioxide into this carbonic acid. Then the carbonic acid, so a buffering system just kind of holds on to the acid. It doesn't necessarily get it out of our body. It can't get it out of our body. It's a buffer system which just holds it as this carbonic acid. But once the carbonic acid travels through the blood and it gets to the lungs, then it can break down into carbon dioxide and water, and we can breathe that carbon dioxide out, and we can get rid of that carbon dioxide through our respiratory system. Okay, so that's one way that we can get rid of the acid that we've been buffering. Then another way that we can get rid of it is if the carbonic acid travels through the blood and it gets to the kidneys, then the kidneys can get rid of that hydrogen by urinating it out, right? So we can either breathe it out as carbon dioxide in the lungs, or we can urinate it out at the kidneys. So in this exercise, what we're looking at is what happens if we have a buildup of carbon dioxide, or we have a buildup of hydrogen, or what if we don't have enough carbon dioxide and we have perhaps don't have enough hydrogen, or we have too much bicarbonate. So that's what this whole worksheet is all about, is we're trying to see, conditions that can upset this, and how we can diagnose this. What are some things that we can do to diagnose? So in order to do that, we have to know, in all of this, we know that the acids in our blood are measured by pH. And we've said that we've always known since general A&P that the normal blood pH is 7.35 to 7.45. And we've said that anything that's under 7.35 is going to be an acid. So what this means is if you have an acidic pH, that means that you have lots of hydrogen. There's too many hydrogen in there in the blood, or too much carbon dioxide can also, convert then over to too much hydrogen. So we've got too much acids. And so that's going to be anything lower than 7.35. So 7.3, 7.25, lower. Anything that's over 7.45 means we don't have enough hydrogen, or we have too much bicarbonate. And so that's going to be what we call more alkaline. Okay, so when we are looking at, we draw blood out of our arteries, and that's what we call arterial blood gases. When we're pulling blood out of the arteries, and then we start to look at the components in the blood. So we'll look at the pH, and then the next thing that we're going to look at is the carbon dioxide. And carbon dioxide, the typical range of carbon dioxide, if you remember from the respiratory system, we always talked about 40 millimeters of mercury or 45 millimeters of mercury. The levels of carbon dioxide are typically 35 to 45 millimeters of mercury. Now, carbon dioxide is an acid, so anything more than 45 would be acidic, and anything less than 35 would be an alkaline. So if we wanted to put it on our scale here, where we kept the acid this way and the alkaline this way, we'd flip that 35 to 45 around, and we would say 45 to 35. Because anything more than 45 would be acidic, and anything less than 35 would be alkaline. So we just kind of flip those around when we're going through this worksheet. And then lastly, we look at the bicarbonate. And so bicarbonate, the normal bicarbonate, which is this right here, that is normally 22 to 26. So bicarbonate, this is an alkaline molecule to begin with. So anything over 26 is going to be alkaline. Anything under 22 is going to be acidic. So we have, if we say 22 to 26, anything over that 26 is alkaline, and anything under 22 is going to be acidic. And this is what you're going to have to memorize in order to do that worksheet. Okay, so we're going to look at different scenarios, and we're going to try to figure out all of those different things on our worksheet using this scale. So what I'm going to do is I'm going to take my whiteboard, I'm going to clear it. You won't be giving this on the exam, so you want to make sure that you're writing this out. So you can write pH, and you can say, you know, 7.35 to 7.45, you know, like that. That might help you. You can say your CO2 is going to be 45 to 35. And then you can say that your bicarbonate is 22 to 26. So anything this way is going to be alkaline, and anything this way is going to be acidic. Right, so we don't even really have to do tic-tac-toe or Rome method. I gotta open this. Okay, this bicarbonate. So we don't have to do either one of those. We can figure out all of these just by looking at this. So the first one that we're looking at on this acid-base worksheet says a patient presents with a history of disorientation and muscle twitching, history of uncontrolled diabetes, presents with Kussmaul respirations, which is kind of a type of hyperventilation, and the respirations are deep and labored. And this person has a pH of 7.25. They have a CO2, which is the partial pressure of CO2, which is 27 millimeters of mercury, and their bicarbonate is 20, right? So just by looking at this, we know that the pH 7.25, that's really low. So this person has an acid problem. Their pH is too low. When we look at carbon dioxide, and we said 35 to 45 is the normal, we can see that this is a lot less than 35. So this person, you know, and if we go up here, we can see that 27 is less than 35. This person, their CO2 levels are making their blood more alkaline. If we look at the bicarbonate, then the bicarbonate is 20. So bicarbonate is actually low. So anything less than 22 is acidic, right? So we can see here then that the pH is acidic and the bicarbonate is acidic. Now the bicarbonate, this is what's created in the kidneys. And so when we talk about the kidneys, we talk about it would be a metabolic problem. It's not coming from the respiratory system. It's actually coming from the kidneys. It's coming from how the kidneys are, you know, breaking that carbonic acid into bicarbonate and hydrogen. So it's a metabolic problem because it's where the acid is coming from, causing the pH to be low. So this is a metabolic acidosis. So without doing the tic-tac-toe or the Rome method, we can figure it out that way. Then if we looked at the CO2 levels, the CO2 levels are not normal. They're 27. So that means that they are alkaline. And so it's going in the exact opposite direction. So we know that there is some compensation going on. If there was no compensation going on, the CO2 would be normal. It would be normal because the body hasn't even started to try to correct this problem. But what we see is that the CO2 is not normal and it is trying hard to correct the problem. So we know its compensation is going on. We know it's not fully compensated though, because the pH is not normal. It's still acidic. So we can say that this is only partial compensation.
Can I ask a question? Because I
You bet.
actually got it wrong. I tried, but
Okay.
I
Sure.
called it respiratory alkalosis, which, yes, it's like trying to compensate. But so when both numbers are off, how do you know which one is truly the issue? Does that make
Okay,
sense?
great question. You always have to look at the pH first because that's what matters. These levels we're looking at to try to determine what's going on, but it's the pH that matters. So this pH is acidic. 7.25 is lower than normal. So it can't, just based on that, it can't be an alkalosis. And from
Oh,
there,
so that's where it would have
yep,
been my key that my answer was not correct.
yep, you always look at the pH first. And from there, then you try to see, well, what system is failing? What system's creating this, the acidity or the acidosis or the alkalosis?
Okay, so I look to see if it's acidic. If it's acidic, then I look to see which one is acidic, and that is the issue. And so in
Yep.
this case, it's metabolic, which is acidic, and the other one is just trying to compensate for the acidity.
Exactly.
Okay.
That's
Okay.
perfect, Catherine.
I'm feeling like I might have more where I think in the video, I just thought it was a very good video. Thank you. I guess I just thought that, and I don't know why it sounds stupid when I say it, but I thought like, oh, if the respiratory is the issue, then like, I don't even know what I'm saying, but like, oh, okay, the respiratory, I guess what I'm saying is I thought the respiratory maybe took precedent over the metabolic.
Yeah, I mean, there's your systems are always trying to compensate for each other. So when the kidneys aren't doing their job and it's not, we're not getting the problem is there, the respiratory system is going to try to compensate to correct it, and then vice versa. So I completely understand your thought process.
Yeah.
The best thing is to just look at the pH first. That's really great though, Catherine, that you're thinking about it this way. Now, when we do this Rome method, or when we do tic-tac-toe, tic-tac-toe is just a fun way to say, so this is acidic on this side, normal here, and then alkaline here. So what we do is first look at pH. pH is 7.25. 7.25 is acidic, so we put that there. PCO2, the CO2 is 27. 27 at CO2 we said was alkaline, so CO2 is alkaline over here. Bicarbonate is 20. Bicarbonate would be on the acidic range, so PCO3 goes over here, and here we have our tic-tac-toe. So we know HCO3 is metabolic, pH is acidic, so we can say this is metabolic acidosis. So we can figure it out that way. Alkaline, the CO2 is not normal. Because it's not normal, it's telling us it's trying to swing way to the other side to try to compensate. That tells us that it's partially compensated. If the CO2 were normal in here, then we would say, oh, you know what? The respiratory system hasn't even tried to correct this. So then it would be uncompensated. But what we see is the respiratory system has gone all the way to the alkalosis side. So it's trying to compensate for this acidosis problem. Okay. So there we have that. Any questions on that one? Any other ones? Good. Okay. So the next question, we're looking at a patient and then it said, to circle which ones are confirming the clues. Well, you have uncontrolled diabetes is always definitely a clue. A person that has uncontrolled diabetes oftentimes has this metabolic acidosis. So that's always a definite clue. And then, they're compensating by the respiratory system's trying to compensate by hyperventilating. They're trying to get that acid out, trying to blow out that carbon dioxide and lower the CO2 levels so that hydrogen can bind to bicarbonate to become the buffer, the carbonic acid. So there's that. Now the next one, number 2, patient presents with seizures and deep rapid breathing. So here we have the pH is 7.5. The CO2 is 22, and the bicarbonate is 20. So right away, pH is 7.5. Our normal is 7.35 to 7.45. So the pH here is alkaline. The CO2 is 22. We said that the CO2 normally is 35 to 45. Anything under 35 is going to be alkaline. Anything over 45 is going to be acidic. So we said that if we have CO2 of 22, that's going to be very alkaline. And then our bicarbonate is usually 22 to 26. And so this is 20, so 22 is going to be on the acidic side. And again, if you have to draw this out for pH, CO2 and HCO3, I recommend that. So you know, 7.35 to 7.45, 45, 35, 22, 26. You know, you can always draw that, write that out. You'll be able to have a piece of paper and a pencil. So here we see that the pH is alkalosis. So what's causing that alkalosis? Well, it looks here like it's the respiratory system. CO2 is the respiratory system. So what this means is that your respiratory system is blowing out too much carbon dioxide, and it should normally, you know, be much higher than that. It should be between 35 and 45. So you're blowing out too much carbon dioxide, making it alkalosis. So this is a respiratory alkalosis. All right. Now, how did we, and what's happening with the other system? So with the kidney, we see that it's acidic. So we have partial compensation because this is not normal. 20 is not normal. It's actually acidic. So it's trying to go the exact opposite. So it's partial compensation. And what would be causing this in the deep rapid breathing? So you're rapidly breathing and you're pushing out too much CO2. So when you're pushing out CO2, that means you're getting too much CO2 out of your blood. Your CO2 levels are really low, and your kidneys are trying to compensate by, you know, trying to build up more acid, and that's what they're trying to do. Now, if we look at the Tic-Tac-Toe method, because this is a great way to go and just to confirm what you think is happening based on your thought process. If you look at pH again, pH is 7.5, so that is alkaline, so we put pH right there. CO2 is very low, so CO2 is alkaline. And then bicarbonate is 20, bicarbonate is low, so that means that our bicarbonate is acidic. Okay, and so that tic-tac-toe right there, that tells us that that is respiratory alkalosis. So we have a respiratory alkalosis. And this is way over on the other side, so it's partially compensated. Now, another thing I didn't talk about in that first one is this Rome method. This is another method that's really it's a quicker way to look at it, but Rome means respiratory opposite, metabolic equal. So in this, what we're looking at are hydrogen. We're comparing hydrogen and carbon dioxide, okay? So with, I don't need that plus sign, hydrogen and carbon dioxide. So in this case, let's take a look at our hydrogen. Hydrogen is pH. So if you have a lot of pH, then you're gonna have decreased, if your pH is decreased, you have a lot of hydrogen. If your pH is increased, then you don't have very many hydrogen, all right? So with this, we look at our pH is 7.5, which is alkaline. So we actually have our pH in this case is increased, which means that our hydrogen are going to be decreased. And then we look at CO2, and CO2 is 22, and normally the CO2 should be between 35 and 45, so the CO2 is decreased. Okay, so in this case, these are opposite from each other. The hydrogen are going, oops, hang on a second. What did I just say? CO2, hydrogen. Maybe it is the pH. I always, on the Rome method, I always tend to get this mixed up. The hydrogen are going down, so maybe it is pH. So in this case, pH is going up. Yeah, it's pH. You don't have to do hydrogen. I don't use the Rome method very much. So we'll look at pH and we'll look at carbon dioxide. So pH is going up, carbon dioxide is going down. That's respiratory is opposite. So they're going in opposite directions. That tells us that it's the respiratory system, and the pH tells us that it's an alkalosis. So that's a quick check at looking at that. And then you have to look at the opposite system, which is bicarbonate, to see if that is compensating or not. So I'll go on to the next one so you can see that next one. I didn't mean to mix you up. I just don't use the Rome method very much. The next one that we're talking about, the patient presents with nausea and vomiting after having ingested 4 rolls of antacids for his heartburn. Respirations are slow, ECG shows arrhythmias. So in this case, our pH is 7.48. Our CO2 is 50. And our HCO3, our bicarbonate, is 28. Okay. pH normal 7.35 to 7.45. So this is higher than normal. So this is alkaline. CO2 is normally 35 to 45. This is high. So a high CO2 means that it is acidic. HCO3 is 28, normal is 22 to 26. So this is high. High bicarbonate means that it's alkaline. So our pH and our bicarbonate are the ones that are matching. So we say that this person has a metabolic alkalosis. Metabolic alkalosis, okay? Now the opposite system is the CO2, is the respiratory system, and it's not normal. It's actually going the opposite direction. It's acidic. So we say that this is partially compensated. Partially compensated, okay? So what is happening with this person is if we look at their, they've ingested antacids. Well, what are antacids? Antacids are bicarbonate. That's what it is. It's a sodium bicarbonate. So they're artificially putting bicarbonate into their blood. That's what they're doing. So by ingesting those 4 rolls of antacids, that's what's happened. Their respiratory system then is at a 50, which means that it is trying to compensate for that and make the blood more acidic. All right, so it's going to slow down those respirations so you're not breathing out as much carbon dioxide. So the carbon dioxide builds up in the blood, and that's going to cause the blood to become more acidic. So if we do this tic-tac-toe method again, this is normal, this is acidic over here, this is alkaline over here. This is what our tic-tac-toe looks like. pH is 7.48, so that's alkaline. Carbon dioxide is 50, and when we said, when we're doing this here, anything over 45 is acidic. So we say that our CO2 is causing the blood to be acidic. And then our bicarbonate is 28. We said 22 to 26. Anything over 26 is making it alkaline. So our bicarbonate goes over here. And so we get this tic-tac-toe. The pH is alkaline, so it's an alkalosis, and it is the, it's kidneys or the metabolic system that's causing it. So that's metabolic alkalosis. And because this CO2 is way over on the other side, making the blood more acidic, we say that it's partially compensated. Okay. If you want to double check that with the Rome method, we look at the pH and we look at the CO2. pH is 7.48. It's usually 7.35 to 7.45, so pH is going up. And CO2 is 50, and 50, it's normally 35 to 45, so the CO2 is going up. So this means they're going in the same direction, which is what metabolic equal means. So that tells you that it is a metabolic problem because the arrows are going in the same direction. And then you look at the pH again and say, okay, they're going in the same direction. What direction are they going? They're going in alkalosis. They're becoming more alkalosis. So it's metabolic, and then it would be alkalosis because of the pH. Okay. So that's that one. And all right, so that's what we have for that one then. Any questions on that one? Doing pretty good. All right, starting to really get it? Starting to get it? Okay, good. The next one we look at, a patient presents with an overdose of heroin. Their respiratory rate is 8 breaths per minute. Normally you're looking at 12 or more breaths per minute for sure. So in this one, we have a pH of 7.3, CO2 of 50, and a bicarbonate of 28, right? All right, so we look at pH 7.35 to 7.45. So this is low, so we know that that's acidic. CO2 is 50, normal is 35 to 45, 50 then would be acidic. And then bicarbonate is 28, 22 to 26 is normal. And this one is, so this one is going to be alkaline because anything 22 to 26, anything over 26 is going to be on that alkaline side. So keep going back to that chart where is it going acidic or is it going alkaline? Okay, to put all your values in there. So what do we have? We have a match here. So we know that this is an acidosis and it's caused by the respiratory system. So this is respiratory acidosis. And then we look at the other system, we look at the metabolic system, the kidneys, and the kidneys are compensating, but it's still only partial compensation because that pH is not normal. So we still have partial compensation. We look at our history and we see they have respiratory acidosis. So respiratory acidosis, when you're thinking of that, you're thinking, okay, well, you're not getting the carbon dioxide out. The respiratory system is not getting the carbon dioxide out, and the carbon dioxide is building up in the blood. So we look at this and we look at heroin. Well, one of the things, heroin affects the respiratory centers in the brain, and it doesn't allow you to breathe. It slows, it depresses your respiratory system, so you're not breathing out. And it really decreases your respiratory rate. So the heroin and the respiratory rate being decreased is a huge clue on what's going on. And so they might, they might actually need, it depends on how low it goes, but they might actually need to get some, what is that called? To compensate for heroin.
Is it Narcan?
Yes, thank you. Narcan. Yes, thank you. That's, mine went blank. Okay, tic-tac-toe. If we look at tic-tac-toe, we've got normal here, we've got acid here, we have alkaline here. So our pH is acidic, 7.35 is acidic. Our CO2, 50, the top end is 45. So CO2 is acidic. HCO3, 22 to 26, anything over 26 is alkaline. So bicarbonate is acidic. Wait a minute. What did I do wrong here? Oh, I put pH. Okay. There we go. So I messed up here on my brain is starting to go on me. Normal. So we have acid over here, alkaline over here. Okay, so our pH is 7.3, that's acidic. Our CO2 is 50, that's acidic. Our HCO3 is over 26, that is alkaline. Sorry about that. I have to be more careful. So that is tic-tac-toe. That's telling us that the respiratory system is causing the acidosis. And the kidneys are partially compensating. They're not normal. They are trying to help out, but they're not able to get that pH normal. Then if we look at the Rome method, we look at the pH. The pH is 7.35, so the pH is going down. We look at the CO2 35 to 45, it's at 50. CO2 is going up. This is respiratory system because respiratory system is opposite, respiratory opposite. So we know that's a respiratory problem. And then we look at the pH and we say, well, it's acidic. The pH is acidic, so it's respiratory acidosis. So that's how the Rome method would work. Okay. All right. So then we go to the next one and clear my board. Okay. So the next one, the patient presents with a history of acute extensive diarrhea. The pH is 7.2. The CO2 is 40. The bicarbonate is 21. All right, so 7.35 to 7.45, we know that pH is acidic. CO2 is 40, and we said that 35 to 45 is normal. So anything under 35 is, well, 35 to 45 is normal. CO2 then is normal, right? So that's normal. And then our bicarbonate is 22 to 26 is going to be normal. And our bicarbonate is low. So we said that's going to be acidic. So if we look at this, we see that the pH and the bicarbonate match. So this is metabolic and the pH is low. So this is metabolic acidosis. We look at the opposite system, the respiratory system, and that's normal. So what that tells us is the respiratory system has not yet started to try to combat this, to try to get rid of the acidosis. So we say that this is uncompensated. It's uncompensated because the opposite system is normal. If it were trying to help, it would go towards the alkaline way, and the CO2 would be decreased below 35. Below 35. So, all right. So we are thinking it's a metabolic acidosis. Now let's look at our history. Our history says that we have extensive diarrhea. All right. So what is happening with diarrhea? Now, diarrhea starts in the intestines, right? So in your small intestine, you have the pancreas that is dumping in loads and loads of bicarbonate, right? That's what the pancreas does. One of the things that it does, secretin causes it to produce bicarbonate. Well, with diarrhea, you're losing all of that bicarbonate. And so then the blood, you're going to be pulling more bicarbonate out of the blood in order to, for the pancreas to be able to create more bicarbonate. So you're losing lots and lots and lots of bicarbonate. So that's what's making the bicarbonate levels lower. You've got to try to replace that, and you're losing so much of it in the diarrhea. So that kind of explains then that diarrhea explains why you're getting rid of so much bicarbonate, which you know, if you get rid of the alkaline component, the alkaline molecule in your body, then your blood's going to be more acidic. So then we look at tic-tac-toe, and we see this is acid, this is alkaline. So pH is 7.2, so that's going to be acidic. We look at CO2 is 40, so that's going to be normal. And then we look at bicarbonate, which is 21, and that is also acidic. And so tic-tac-toe, we have, oops, I should have put bicarbonate. Tic-tac-toe, we have metabolic acidosis. And is it compensated? No, CO2 has not done, the respiratory system has not done a thing yet to try to compensate for that. So this is uncompensated metabolic acidosis. If we look at Rome, we look at the pH, 7.2, so pH is going down. We look at CO2, CO2 is 40, which is normal. Okay, well, Rome doesn't really work in that kind of situation then. Then we have to go a little bit more investigative. All right, then, so I'm gonna clear this. Any questions on that one? Okay, the next one we're gonna go to is number 6. So in 6, we have a severely obese patient with deep labored breathing. In the office, he appears lethargic. He has a mildly depressed level of consciousness. He's difficult to arouse even with a sternal rub by rubbing on the sternum. So let's look at what's going on with his arterial blood gases. So we have a pH of 7.36. We have a CO2 of 55, and we have a bicarbonate of 30. Okay, so 7.35 to 7.45. So pH is normal. So you're thinking, okay, that's within normal limits. Let's look at, see what's going on with CO2 and bicarbonate. So CO2 is 55. We said that anything over 45 is going to be acidic. Oh, wait a minute. Yep. And then bicarbonate is 30, and we said that 22 to 26 is normal, so anything over 26 is going to be alkaline. All right. So we do have an issue here because we have, you know, the respiratory system and the metabolic system are not normal. So there is something going on, but our pH is normal. So if the pH is normal, that just tells us right away that it is fully compensated. That's what the normal pH is telling us. But then we look to see, well, at what range is it? Is it closer to 7.35 or is it closer to 7.45? Well, it's closer to 7.35. So that tells us that this is an acidosis, because 7.35, anything lower than 7.35 is an acid. It's an acidosis problem. So we know that it's an acidosis. What's causing the acidosis then? Here we see that it's going to be respiratory. So the respiratory system is causing the acidosis. The bicarbonate, the metabolic system, so the kidneys are doing a fantastic job of compensating for that, and it went high enough to cause the blood to be more alkaline so that it's fully compensating that and helping that pH to be normal. How do we see that on tic-tac-toe? pH is normal. CO2 is more on the acidic side. It's higher than 45, so CO2 is acidic. Bicarbonate is higher than 26, so bicarbonate is more alkaline. So this is what we're going to see. It's going to look like this. The pH is the first thing we look at, and we can see that it's closer to 7.35, so we say that it is definitely an acidosis problem. Now we want to say, okay, we want to look to see which of these is actually causing the issue. And so we're going to look to see which one is furthest from normal. So I don't know if I did this one right up here. Let me look. We're going to see which one is furthest from normal. And the one that's furthest from normal is going to be the one that's causing the problem. So CO2 is at 55, and we said 45 is the top end of that. So 55 minus 45, that's actually 10 away from normal. Bicarbonate is 30. We said the high range is 26. So 30 minus 26 is 4. So it is the respiratory system that's bringing it further away from normal. So we would say that this is a respiratory acidosis. Respiratory acidosis. So with our Rome method, we could try to make this work. Our pH is starting to decrease because it's at the pretty low end of normal. And then our CO2 here is increased. So that tells us there that it's respiratory. And because it's going towards the acid, it tells us that it's respiratory acidosis. So those are just different ways of looking at what's going on, okay? If we look at again, looking at the history of this person, they have deep labored breathing. So he's breathing out. The deep labored breathing means that he's having trouble. He's a couple of things. First of all, severely obese patients. So that extra weight is putting a lot of pressure on the lungs, and it's hard to push that CO2 out when there's so much weight on those lungs. And that is evidenced by his labored breathing. He can't get the air out. He can't get the CO2 out. So he's not getting that CO2 out. And so that CO2 is staying inside the blood, causing the blood to be acidic. And it's the respiratory system, because of that breathing issue. That's what's going on with that breathing. All right, so clear that. You guys jump in if you have any questions. We've got 2 more. So here we have a patient that's having his overdosing on aspirin. So the pH here is 7.44. The CO2 is 32, and the bicarbonate is 20, right? So we look at the pH. The pH is normal, but it's on the high end of normal, but it's normal. So it's within normal limits. The CO2 is, again, we said 35 to 45 is normal. Anything that's under 35 is going to be alkaline because it's low. So it's low, so it's going to be more alkaline. The bicarbonate is 20 and 22 to 26 is normal. Anything lower than 22 is going to be acidic, right? Now, when we look at this again, we see that the pH is going towards the more alkaline. So we're kind of thinking that it's going to be respiratory alkalosis. That's what we're kind of looking at. And we see that the bicarbonate here then is, it is lower. So it's trying to compensate. So we say that it is fully compensated. And the reason why it's fully compensated is because that pH is within normal limits. We look at our history and we see that aspirin, so they've had an overdose of aspirin. Now what aspirin tends to do is it has an effect on the respiratory system. It's going to affect, when there's too much aspirin, it affects the respiratory system, and it's going to cause the respiratory system to increase, and you're going to blow out more carbon dioxide. So initially in an aspirin overdose, a person will have a respiratory alkalosis. If it's not corrected, eventually that'll turn into a metabolic acidosis, because aspirin is quite acidic and it will cause a metabolic acidosis. But initially we tend to get like a respiratory alkalosis. So if we do that tic-tac-toe method again to see if this is what's going on again, so we've got acid over on this side, alkaline over on this side. Our pH is normal, but it's on the alkaline side. The CO2 is 32, and so that's alkaline. And then the bicarbonate is 20, and that's too low, so we say bicarbonate is acidic. So that gives us a tic-tac-toe of respiratory alkalosis. Okay, now, well, let's look at this, because what we want to do is we want to go back to the systems and we want to see which one's furthest from normal. We know pH is more alkaline because it's closer to the alkaline side, but let's look to see. Now, normally the respiratory system, 35 minus 32, that's going to be 3. So it's 3 away from normal, whereas the bicarbonate is 20 and the normal low end is 22. So 22 minus 20 is 2. We go with the higher number. That's the system that's causing the problem. So we have respiratory, and we know that it's going towards alkaline. It's high, it's closer to alkaline, so it's respiratory alkalosis. If we used the Rome method, we could say that the pH is going up. It's closer to 7.45, and CO2 is 32. So we say that CO2 is going down. So it would be respiratory opposite. So this is the respiratory system. And because the pH is closer to alkalosis, we'd say it's respiratory alkalosis. So we've got 3 different things that are telling us what's going on, and the history is confirming that that's probably what's going on. Okay, now one last one that we're going to go through here is the marathon runner collapses at the finish line from exhaustion. He has severe muscle cramps and pain. So his pH is 7.36, CO2 is 37, and bicarbonate is 18. Okay, so 37. All right, so our 7.36, 7.35 to 7.45, so we know that this is slightly alkaline. Oh wait, 7.35 to 7.45, what am I thinking? 7.35 to 7.45, so 7.35 is acidic, so it's normal, but it's closer to acidic. Okay, 7.3, okay, so it's closer to acidic. And we said that the CO2 is 37, and so 35, darn, what am I doing here? 35 to 45 is normal. CO2 is 37. We said that anything that's under 37 is going to be alkaline because it's low CO2, so it's alkaline. Bicarbonate is 18. 22 to 26 is normal, so it is less than 22, so it is going to be acidic.
Isn't the CO2 normal though?
CO2 is, oh yeah, so this is normal. Sorry. You're right.
It's okay.
Yeah, I'm just, my brain starts to go after a while.
I can imagine.
Yeah, thank you. That's why I have you guys here.
Right?
All right, so that's normal. So pH is normal, CO2 is normal, and the bicarbonate is acidic. So what we have going on here is we have the blood is becoming more acidic. So we know that And the bicarbonate is more acidic. So we know that this is going to be a metabolic problem. So we've got a metabolic acidosis. Now what happens here, if we look at our runner, our marathon runner, a lot of times the muscles start to produce a lactic acid if you are not getting in enough oxygen, if your muscles aren't able to make enough ATP, they start to build up lactic acid. Pyruvic acid gets converted to lactic acid. We get a buildup of lactic acid, and that causes a lot of pain and muscle cramps. And so that would make sense that this is a metabolic problem because the acid is occurring through metabolic processes, and it's creating acid. Now, the respiratory system is normal, so it's getting close to being abnormal. It's getting close to being alkaline, but it's still within normal. So we would still have to say that this is uncompensated, because that is still, it's still normal. So if we do our tic-tac-toe.
Are we on number 8?
That's where I am. Is that where you are?
Yeah, I'm just confused because my number, I have 7.36. For CO2, it says 20, and HCO3, it says 20.
Oh, that's weird, because
So-
mine match with hers.
So that is weird. So at the end of last term, I put a new worksheet on there because I probably had those numbers, Abigail, and as I was going through them, they weren't working out the best. So I switched those numbers. I don't know why you're getting the old document. That's kind of odd. Did you just download it?
No.
I have the old document too. I have 20 and 20.
Oh, you do?
It's all
Okay.
printed out and stuff too, but so far that was the only one that was like different from yours.
Different. Okay. Oh, there's 2 more after this. I forgot. Okay, I see that there's 2 more. Well, follow along with my numbers and just change your numbers on the sheet to my numbers.
Okay.
I'll have to figure out why you're still able to, I'll have to delete that other file completely so that the only file you students are able to download would be this correct one. So use my numbers because that's on the corrected worksheet.
What does the CO2 number say?
So the CO2 is 37 and the bicarbonate's 18 and pH is 7.36. I think the other 2 that are left too might have different numbers. So we'll go over those 2. I'll make sure you have the right ones. Just jump in again too if you have questions. So when we look at the tic-tac-toe for this, 7.36, as that's the pH is normal. CO2 is 37. So 37 CO2 is normal. And then bicarbonate is 18. And so this is acidic. So the bicarbonate is acidic. Now we know that the pH is towards the acidic side. So we could say that that would have been a tic-tac-toe if it were just a couple more over. So that would be a metabolic acidosis. And it's completely uncompensated because carbon dioxide is not even trying to compensate. It's not trying to go in that direction. So uncompensated.
Can you, for some reason, I thought if it was normal, that meant it was completely compensated. So I must have it backwards, right? Can you re-explain what would show us fully compensated?
No, you're right. It is compensated. It's completely compensated.
Oh, okay. I'm sorry.
I wonder if I was using the other sheets. What were the numbers can you tell me your numbers that you have, Abigail? I can't tell which one was what's your pH on this?
For which number?
Number 8.
Number 8 is 7.36.
Okay.
The PCO2 is 20. And then the HCO3 was also 20.
Which is funny because I have the sheet that matches
Mine.
the example that you just did.
I don't know. That's just so bizarre. I'm trying to figure out which one was, what was the CO2? 20?
Yeah, the PCO2 and CO3 was 20.
Okay. Well, let me just see really quick. So 7.36, that's normal. Okay, it's
I think the
normal.
only thing that was different that I had the PCO2 was alkaline.
Okay. The CO2 is normally 22 to 26. It's low, so it would be alkaline. And the CO3 is 20, and that's low, so that would be acidic. So in this case, it would be a metabolic acidosis, so we still get the same thing. And since the pH is normal, it is fully compensated. I think that you have the newer sheet. I don't know why I printed off the old sheet. So metabolic compensation. So if we do our tic-tac-toe, normal, acid, alkaline, pH is normal, but it's headed in the acidic direction. CO2 is alkaline and bicarbonate is acidic. So here's our tic-tac-toe. It's metabolic acidosis, but it's fully compensated because that pH is normal. If we look at which one's furthest from normal, the carbon dioxide is 20. And then that's not going to work out because then it would be respiratory. Yeah, you have somehow, I think you have the old one. That's very bizarre.
I don't know how, but I changed the numbers to the one that you had on your document.
This morning, I actually printed the document off of Canvas and went through these problems from the document that I printed off. I'm sorry, I have no idea how you got the old document. So, all right.
That's okay.
Well,
I hope it's just that one problem that's different though.
I think that I changed the three, we'll see. I thought that I changed the last 3 questions, but you'll just use my numbers instead. Okay?
Okay, sounds good.
Okay, so let's go through the last 2 questions then. Here we have a patient presenting with a history of COPD. We already know that a person that breathes, they can't breathe out. Breathing is labored and fast. So we look at their pH and their pH is 7.31. Their carbon dioxide is 50 and their bicarbonate is 26. Do you have those numbers?
Yeah, those are all the same.
Oh, okay. Okay, so when we look at this, 7.35 is normal, 7.31 would be acidic. 35 to 45 is normal, increased in CO2 would be acidic. And then bicarbonate is 26, 22 to 26 is normal. So this is within normal limits. So we know right away that we have a respiratory acidosis. And we also know that the other system, the kidneys, are not compensating. So it is just uncompensated. It's not even partially compensated, so it's uncompensated. We do our tic-tac-toe method. We have normal, acid, alkaline. So our pH is 7.31. That's on the acid side. Carbon dioxide is 50. It's above 45, so that's on the acid side. Bicarbonate is 26. That's going to be right in the middle because that's still normal. 22 to 26 is normal. There's our tic-tac-toe, respiratory acidosis. And then here, this is sitting at a normal range, so it's uncompensated. If we go and double check it with Rome, we have our pH is 7.31, so pH is down, 50 for CO2, 35 to 45, so CO2 is going up, so it's respiratory. And then the pH is acidic, so it's respiratory acidosis. So we would expect that because because of his COPD, he can't breathe out. So he's holding that carbon dioxide in, making his blood more acidic. And so that, now the last one, finally, we get to, here we have a patient presenting with a history of acute excessive self-induced vomiting. So here the pH is 7.44. The CO2 is 47. And the bicarbonate is 32. Do you have those numbers, Abigail?
You said 7.44
Yeah,
and then 47,
and then 32.
32. Yeah,
Okay.
that's all the same.
Okay, good. Okay, good. So pH 7.35 to 7.45. So pH is within normal limits. CO2 is 47. 35 to 45 is normal. This is higher than normal, so that's acidic. Too much carbon dioxide is an acid problem. Bicarbonate 22 to 26 is normal. This is 32. So that is above 26, so that's going to be alkaline. All right, so now we have to figure out which direction are we going. Well, 7.44 is headed towards alkaline, so it's really going to be an alkaline problem. So we have metabolic alkalosis. Metabolic alkalosis. Okay, that's going to be our issue. Now, if we look at tic-tac-toe, just always to double check. 7.44 is normal, so the pH is normal, but it's headed towards alkaline. CO2 is 47, so 47 is 35 to 45 is normal. Anything over 45 is going to be acidic. Bicarbonate 22 to 26, anything over 26 is going to be alkaline. So there's our tic-tac-toe. So we've got metabolic alkalosis. If we do, and because the pH is normal, we have to say that it's fully compensated, no matter what. If that pH is normal, it's fully compensated. The two systems have worked together to make it normal. And then if we do Rome, the Rome method, we look at the pH. The pH is 7.44, so it's normal, but it's going up. And then the CO2 is 47. 35 to 45 is normal, so it's above, it's also going up. So these are going in the same direction, so it's metabolic equal. That tells us that it's metabolic. We go back and look at the pH. The pH is more alkaline, so it's metabolic alkalosis. Now we look at the history, and the history says vomiting. So this is different than the intestines. So in the stomach, the stomach's producing a great amount of hydrochloric acid. So we have this like barrier here. If you're vomiting, you're getting rid of hydrochloric acid. If you are having diarrhea, you're getting rid of bicarbonate, okay? So you're vomiting all of this hydrochloric acid, you're getting rid of all that hydrochloric acid, you're gonna be pulling in more hydrogen from your blood to make more hydrochloric acid. So you're pulling out that hydrogen and you're making your blood more alkaline. That's what happens when you're vomiting. All right, so any questions on those? Okay, I'm going to go into the anion gap right away if you guys don't have questions. There's only 4 questions here, so, and hopefully it'll be easier. The anion, if you think of, this is the anion gap. So anions are negatively charged molecules, and the negatively charged molecules we're going to look at are chloride, and we're going to look at bicarbonate. So these two. Now we also have cations, and the main cation in the body is sodium. So what we're going to do is we're going to look at the difference between the cations and the anions, and that will tell us what the anion gap is, right? So the normal anion gap is anywhere between 3 and 10 milliequivalents per liter. And mostly anything over 10 is going to be an acidosis. It's going to be an acidic problem. And so we will do this, we'll do the anion gap along with the arterial blood gases to figure out if a person has an acidosis. Anything lower than 3, this is rare. And a lot of times if we see this, we're just going to run that again to see if there was an error. Otherwise, there's a few things that can cause that we'll talk about as we go through some of these issues. So the first question is, again, you're going to be doing, you know, you guys are going to get so sick of doing the ABGs, but you have a pH of 7.5, CO2 32, sodium 138, HCO3 22, and chloride 106. So they want you to calculate the anion gap first. So we take sodium, which is 138, and we're going to subtract the bicarbonate plus the chloride. Bicarbonate is 22, chloride is 106. So this gives us 138 minus 128, which gives us 10. 10 is normal. So this person's within normal limits. Now it also wants you to go through and look at the ABG numbers. So the pH is 7.5. 7.5 is alkaline. So that's high. CO2 is 32. 32 is low. So that's going to be alkaline as well. So we're looking at a respiratory alkalosis going on here. And then the bicarbonate was 22, and 22 is normal. So it's uncompensated. So you've got a respiratory alkalosis going on here that's uncompensated. So, you know, what are some things that could happen, could cause a respiratory alkalosis? Well, you think of hyperventilation. You're pushing out too much carbon dioxide. It's making it alkalosis, an alkalosis. Anxiety can do that. We talked about aspirin, how aspirin affects the brain and makes it affects the respiratory centers in the brain, making you breathe faster. A person on a ventilator can also, this can occur with, you know, when you have a ventilator on a patient, it's forcing them to breathe out faster than they normally would. So that could cause a respiratory alkalosis as well. So that's what we have for that one. Okay, just jump in if you have any questions. Patient number 2, we're looking at pH 7.2, CO2 42, sodium 140, bicarbonate 20, chloride 20. So let's look at the anion gap. The sodium is 140. We subtract the bicarbonate plus the chloride. So bicarbonate plus chloride is 122. So 140 minus 122 is 18. So this is way high. And this tells us that that looks like a definite acidosis issue. So we want to go back and just check our ABG numbers. To look at that, pH is 7.2. So 7.2, that is definitely an acidosis problem. Let's look at the systems to see which one's causing it. CO2 is 42, normal is 35 to 45. Bicarbonate is 20, normal is 22 to 26. So this is definitely a metabolic acidosis. Metabolic acidosis. And so what are some things that cause metabolic acidosis? Well, definitely uncontrolled diabetes is at the top of our list. So when we're looking at that anion gap, especially with one that high, we would definitely want to make sure that they don't have that. And then there's, you know, some other there's some other things that could cause this, but that, I mean, that's the main thing that we would be looking at is uncontrolled diabetes. Right, we look at the next one. Right away, we're going to look at the anion gap. We've got 136 minus 34 plus 100, because that's bicarbonate and that's chloride. So this is 134. So this gives us 136 minus 134, that's 2. So, oops, am I doing the right one?
I was gonna say, I think you skipped number 3.
I skipped one. All right, so I'm doing the last one first. So 2 is way, way low. So the first thing we would actually do is we would redo this lab to see if that's really what's going on. if that is true, it is so rare, but one thing, you know, specific disease, specific cancers like multiple myeloma, that's a cancer of the blood that can sometimes cause that anion gap to be low. But then really anything that causes low levels of albumin. So albumin is a plasma protein. And so this can, low levels of plasma proteins, especially albumin, can cause this anion gap to go lower. And so things that can cause albumin to go lower is kidney disease. Because if you remember in chapter 26, if that glomerulus is damaged, then all those plasma proteins can get out and then they can end up in the urine, and then you no longer have them in the blood. So you'd have low levels of albumin, which is a plasma protein. So that's pretty rare. But with certain cancers and with certain things like kidney diseases that cause lower levels of albumin, you could get that. Okay, then let's do the third one, which I skipped. So our sodium is 140, and we subtract bicarbonate, which is 29, plus chloride, which is 101. So this is 130. So here we get 140 minus 130, that's 10, that's within normal limits. Okay, so we can't get much information from the anion gap, but let's go look at the ABGs. Our pH is 7.0. That is definitely acidic. So we have an acidosis going on, and we look to see which system is causing the acidosis. The CO2 is 60, so that's way over our 45, which is our top range. So this would be a respiratory acidosis. And then our bicarbonate is 29. Our 29 is way high too. 22 to 26 is normal. So 26 is causing the alkalosis. So we can say that it is partially compensated. Okay. There we go.
Can you talk about the reasoning for number 3?
For this one, 3. Okay, respiratory acidosis. So
Yeah.
we don't really have a history on this person, but we do know that respiratory acidosis. So what's happening with a respiratory acidosis is that a person's not breathing out and they're holding the carbon dioxide back into their blood. So this could be a person that has COPD. This could be a person that has, what else? So if they're holding it in, they're not breathing out, maybe they are having other types of hypoventilation. So hypoventilation can be caused from a number of things. It can be caused from brain damage. You know, if the brain is damaged, then your respiratory centers aren't working properly and you're breathing really slow. It can be caused by certain drugs like heroin. So you're not breathing out and all that carbon dioxide is building up inside your blood. So drugs, brain damage, COPD, those are all things that could cause that.
After number 4, I kind of put spaces between them a lot, like when I'm printing them out in Word, but
Sure.
So after number 4, there's a line, I might have made it funny, but it says lower than normal acids, kidney, heart, cancer. So you just explained the the low albumin. But what was the heart portion of that?
So yeah, the heart failure, different heart conditions can cause a low good. You know, I was actually going through that on my own, trying to figure out. So a low anion gap is most of the time caused from low albumin. But they have found it with certain types of heart conditions. And this mostly is going to be because of sodium.
Okay.
Having abnormal sodium levels.
Okay.
it's just so rare to have anything lower than 3
Yeah.
for sure.
Okay.
Yeah,
That portion of it, like the whys are the harder part for me. Like
yeah.
I really have to think about it. So I was just
Yep.
curious.
No, great question. Yep. All right, that's it then. And then that other, the Zoom recording will come up. I'm actually going to go back in and label the Zoom recordings as one will be the acid base, and the other one will be labeled the glomerular filtration rate. So you can go back and watch that one when you get a chance.
Yeah, I was a little confused at the start of this because I printed everything out.
Yeah.
And I'm working on, it says chapter 26 renal system lab activity, but the sheet that you said that you did a video on, I don't have it. I've never seen it before. So then can you just verbally state again what it is? So when we get off Zoom,
Yep.
I have to run somewhere, but right when I get home,
Yeah.
just make sure I know what it is.
So that sheet, if I go back to Zoom here, go to modules. I don't really know how I ended up doing this, but I didn't plan on this, but I ended up putting 2 chapter 6 activities in here, actually 3. Did not plan on doing that at all. So the one that you pulled up was this chapter 26 lab activity.
Oh, yeah, where you have to label.
I know, right?
That one? Okay, so I clearly missed one, is what you're saying.
This glomerular filtration activity is the one that I went over.
Oh, perfect. So it's due on Saturday. What's the one under it due tomorrow? Which one is that?
So tomorrow is this lab activity. This one, gosh, I really want to just delete this. I'm just afraid to delete it because students, it's something that would be good for a review, but I don't want to make it an assignment because it is so, this is the one you printed off.
Oh, is it?
Mm-hmm.
Oh, yeah, it's going to be very time consuming.
It
And
is
I don't
so
just say that just to
time-consuming.
like get out of doing something, but
Yeah,
I don't know. I just
put,
felt like my time, because I always watch the videos twice. So I was like, oh gosh, I wish I could be spending this time watching the lecture again.
I know, well, the problem, I feel bad for people that have already done that activity.
Oh, yeah.
But I
maybe
still, I
extra
want to
credit.
take it out. I'm going to just take it out.
Okay.
And then if people have done it, they've done it. I can put it up here under the review. I will take this Word document from this lab activity and I'll put it under the review. It's still a great, great review. But I'm going to just take it out. I'm sorry for those of you that have already completed it. I'm going to take it out of your being included in your grades. It's a lot. I didn't put any case studies on this week. There won't be any case studies next week either, I don't believe. So next week's this is the last really time consuming week. Next week we'll just be kind of gliding into home base. So.
Well, it will be nice because
yeah,
these aren't due till Saturday, right?
Right.
And
yeah.
we just did 2 of them together.
Right.
So then that just leaves whichever 2 I don't have. So
the one that you're still, well, you'll have to do the urinalysis lab activity.
Okay. So urinalysis.
And the this glomerular filtration is the one that I've pre-recorded, and you'll be able to find that on Zoom.
Okay.
If it's there already.
Well, then it's doable for sure.
Yeah.
Okay.
Cloud recordings.
Well, you just made my day.
Yeah. So this is
sit here for the rest of the day doing this one that you got rid of.
Yeah. I think I can. I thought there was a way to edit it. I'm going to figure out how to edit this and change the, otherwise this one that's already up, that was at 1025. I created that at 1025. That's going to be the glomerular filtration rate. And the next one that starts at 11, that's the one we just went over. So you wouldn't have to watch that.
Okay.
Okay.
Perfect.
All right.
Well,
So
gosh, thanks for all your help.
Yeah, no worries. I'm glad you guys could all make it. It's such a fun thing about, that detective work. I think that's why so many people love the sciences and love healthcare. But if you have any questions, let me know.
Okay.
Okay.
Thank you so much.
Yep, you're welcome.
Great week.
All right. Yeah, you too.
Bye.
Have a nice weekend. Bye-bye.
Thank you.
You're welcome. Bye-bye.